Good morning, students. In this first chapter, force, we will learn about the different effects of it. The different effects means, like we have studied in the previous classes, that a force is a cause which can change the shape, size, and state of a body. State of a body means if the body is in the state of motion, it can come in the state of rest, and if the body is in the state of rest, it can be brought in the state of motion. But the point, a force can change the shape and size. This is only possible when the body is not rigid. Rigid means what? Rigid means the body is hard. So if the body is not so rigid, then its shape or size can be changed, like when we squeeze the toothpaste, its shape changes. So that's why here in this class 10th chapter force, we will learn about the effects when force acts on a rigid body only. So we are going to deal with the effects of force. So first of all, have a notebook, keep writing. Now put the heading force. What is force? So first of all, we will deal with the effects. So its effects can cause translational motion, or it can cause rotational motion. So translational motion can also be categorized as, can also be said as linear motion, so let us understand what is translational motion. So when a force acts on a rigid stationary body which is free to move, the body is free to move means that the body is not fixed to a point, the body is not fixed to the surface, it is free to move, then the force acting on the body lets the body move in a appropriate direction, and that direction will be in the direction of force. So if you apply a force on a stationary rigid body and the body should be free to move, then obviously the body experiences a force in the direction, in its direction, and that motion is called translational or linear motion. Linear motion means the motion in a straight path in the direction of force. Obviously the motion will occur in the direction of force. Now talking about rotational motion. So rotational motion means when a force is applied on a body, so the body starts moving, that there is a turning in the body, and that turning can only be possible when the body is not free, that is, it should be pivoted at a point. So let us understand with the help of figure. Suppose this is a wheel or a circular cardboard, and that cardboard is pinned to the ground with the help of pin. So when a force is applied on the body, on this circular body, that the effects is the rotation. The wheel starts rotating in a particular direction, whether it can be clockwise or it can be anti-clockwise. So this clockwise motion or anti-clockwise motion can only be possible when the body is not free, that is, it should be pivoted at a point. So when a body is pivoted at a point, so the force acting on the body do not produce linear motion, but it produce turning effect in the body, and that turning can be clockwise or it can be anti-clockwise. We can have more figures, we can have more examples, like this is an irregular lamina. It's a cardboard which is simply cut in different shapes, and now I am pivoting the body at this point with the help of a nail, and now a force is applied in this direction. So obviously the body experiences turning effect in anti-clockwise direction. So this is the rotational motion, which can only be possible when the body is pivoted at a point. So what happens when the body is not pivoted? We have already dealt, like we have a ball and that ball is placed over a ground. So when a force is applied over the ball starts rolling, or it starts moving in an appropriate direction. So that is, the body gets displaced. So this is why we call it as translational or linear motion. So just to summarize all the things, you just remember, when force acts on a rigid stationary body and the body is free to move, then the body experiences linear motion. But when the body is not free to move, that is, the body is pivoted at a point, we call it as the body experiences rotational motion. So in this chapter, we won't be studying about the translational or linear motion, but we have to deal with the rotational motion. And this rotational motion is caused by a force when the body is pivoted. So that turning effect is also called moment. We call it as moment. Moment means turning effect of a force, or it can be called torque. Now let us understand what is it actually. So turning effect is how the body which is pivoted at a point reacts when the force acts on it. That is called the turning effect of a force. So again we will consider an irregular shape lamina. So we have a body this way, which is a cardboard simply cut in this shape. So consider a point O. So I am considering this point O as the pivot point. So the body is pivoted at point O, and now I am applying a force in the direction. A force is applied in this direction, which is considered force F. So the moment, or we can say the turning effect of a force or torque, says we need to produce the force along the line. So our force is produced this way. This is the line of action of force. Then this line should be dotted. Okay, so wait. Yes, now the line of force, I have made it dotted. Now it says we have to drop a perpendicular to the line of action of force from this pivoted point. So the perpendicular will be along this direction, hope. Yes, now it seems perpendicular. So this is the perpendicular, that means this is making 90 degree. Now the moment or the turning effect of a force or torque says It is the perpendicular distance between the line of action of force from the pivoted point multiplied the magnitude of force. Or you can define turning effect of a force is the force multiplied by perpendicular distance of the line of action of force from the pivoted point. So that means suppose we have so we can write the formula torque equals to, let this point be P and this magnitude of force be obviously capital F. So force multiplied by perpendicular distance, and what is the perpendicular distance taken? OP. And note, this OP is basically the distance between a point and a line. So the distance between a point and a line will be shortest only if it is perpendicular. So here we can see this OP is taken perpendicular. That means we are talking about the shortest distance between the line of action of force and the pivoted point. So here is the formula for torque. So torque is force multiplied by perpendicular distance, which you have already studied in class 8. So on what factors the turning effect of a force or torque depends? So the factors are, number 1, you will write factors affecting the turning of a body. So the turning of a body is first depends on the magnitude of force. Magnitude means the quantity of force. And number 2, it depends on the perpendicular distance of the line of action of force from the pivoted point, or you can say the axis of rotation. Axis of rotation is the line along about which the body rotates. So that is also called axis of rotation. So this is called the factors affecting the turning effect of a body. And this product is also called the moment of force. So add it, moment of force. And this is the way to measure the moment of force. So moment of force is basically, or torque is equals to the magnitude of force multiplied the perpendicular distance of the line of action of force from the axis of rotation, or you can add from the pivoted point. So there comes a question, how can you maximize the turning effect of a given force? So when it says given force, that means we have a fixed amount of force. So turning not only depends on the magnitude of force, but it also depends on the perpendicular distance. That means we have to apply the force at a point such that its line of action of force will be at the maximum perpendicular distance from the pivoted point. So that means by increasing the perpendicular distance of the line of action of force from the pivoted points results in more turning effects. That's why we have seen many examples here in your book also and in the practical life, that Handles are provided in the doors at the extreme end. Why handles are on the opposite side of the hinges? You know the meaning of hinges. Hinges are the object or about which the door rotates. That is, hinges are called the pivoted points. So hinges are those things about which the door rotates. You can look at your figure in your book, page 3, figure 1.5, there the hinges are marked. That is called the hinges. So you can see the handles are provided at a position such that its distance from the hinges becomes maximum. So maximizing the perpendicular distance results in a lesser force is required to produce the same turning effect than applying the force nearer to the hinge. Right. So if you apply force at the maximum perpendicular distance, you will be required the least force. If you get closer to the pivoted point and try to bring out the same turning effect, you require a larger force. So to overcome this problem, the objects or the things are made such that human efforts can be reduced. So this is all about the lecture first, and now in the further lecture we will continue with what is couple. Thank you all of you.